6.2 grams of a sample is given which contains sodium carbonate, sodium bicarbonate and some non-volatile inert impurity, and this sample on heating loses 5% of its weight, and the remaining residue is dissolved in 100 ml solution, and 10 ml of this solution requires 7.5 ml of 0.2 molar barium chloride solution for complete precipitation of the carbonate, and we need to find out the weight of non-volatile inert impurity present in it. So this is a very big numerical. Let us solve this. And in the first step, you need to recollect one important point from S block elements, that except lithium carbonate, all other carbonates of alkali metals do not decompose in order to liberate carbon dioxide. Means here sodium carbonate on decomposition never give CO2 as that of lithium carbonate or calcium carbonate or magnesium carbonate. When this particular mixture is heated, here the decomposition of only sodium bicarbonate takes place, as sodium carbonate does not undergo decomposition and this is a non-volatile inert impurity. So according to the equation, sodium bicarbonate on decomposition gives sodium carbonate, water and carbon dioxide. And in this case, the loss in mass is because of this water vapor as well as the carbon dioxide escaping out of the vessel. So the loss in mass is only because of these two, and this is the leftover residue. And in the numerical it is given that when 6.2 grams of the sample is heated, the loss in mass is 5%. So here the loss in mass is nothing but 5% of 6.2, and this value is equal to 0.31 grams. Means this much quantity of H2O and CO2 came out whenever 6.2 grams of the sample is heated. Now let us come to the equation. If at all we take 2 into 84 grams of sodium bicarbonate, the loss in mass, it should be totally because of water, which is 18 grams, and carbon dioxide, which is 44 grams. That is 62 grams is the loss in mass, isn't it? As we know that the loss in mass is not at all due to the sodium carbonate taken in the mixture or non-volatile impurity present in the mixture. It is only because of the decomposition of sodium bicarbonate into Na2CO3, H2O and CO2. So when we take 2 moles of sodium bicarbonate, the loss in mass is 62 grams. And here the loss in mass is only 0.31 grams. So what would have been the amount of sodium bicarbonate? It is 0.31 by 62 multiplied by 2 into 84. This value we get it as 0.84 grams. So this is the amount of sodium bicarbonate present initially in the mixture, which is of 6.2 grams. So now we got the mass of sodium bicarbonate. So now we need to get two more values, the sodium carbonate value and finally the answer, which is the non-volatile inert impurity. Let's move further. Now from the equation it is very clear that the residue left over is the sodium carbonate. And now we have sodium carbonate from two different sources. One originally taken and the second one which is formed as a residue. So now the residue is sodium carbonate. And again from the equation, from 2 into 84 grams of sodium bicarbonate, the residue formed is 106 grams. Isn't it? Because we are getting only 1 mole of sodium carbonate. But in this mixture we are having only 0.84 grams of sodium bicarbonate. So what will be the residue formed here? It is 0.84 by 2 into 84 multiplied by 106. Solve this, you will be getting the value as 0.53 grams of sodium carbonate. What is the 0.53 grams of sodium carbonate? So this is the sodium carbonate which is formed as a residue. So now we need to find out what is the sodium carbonate present in the original mixture, and for that one only the second part of the question is useful. The residue is dissolved in water to form 100 ml of solution, and 10 ml of this solution requires certain quantity of barium chloride for complete precipitation of carbonates. So to the aqueous solution of sodium carbonate, we are adding aqueous solution of barium chloride. So what is happening here? The sodium carbonate is reacting with barium chloride in the ratio of 1:1 in order to give barium carbonate. So the entire barium carbonate is precipitated here. So as both are reacting in the ratio of 1:1, now I can simply say that M1V1 is equal to M2V2. So how much quantity of sodium carbonate we are taking? We made it 100 ml solution, but we are taking only 10 ml of that one, which requires 0.2 molar 7.5 ml of barium chloride solution. So we can definitely calculate the molarity of sodium carbonate, and this becomes 0.15 molar. What is this one? This is the molarity of sodium carbonate solution. And in this solution, the sodium carbonate, we got it from the residue part as well as the one which is taken originally. Then you know, by using the basic formula of molarity, that is molarity is equal to weight upon gram molecular weight into 1000 by volume of solution in milliliters, we can calculate the mass of sodium carbonate, isn't it? Molarity is 0.15. The mass we need to calculate, gram molecular mass is 106, then 1000 divided by 100 ml, because we had made a solution of 100 ml. So on calculating, you will be getting the mass of sodium carbonate as 1.59 grams. So what is this one? This is the mass of sodium carbonate present in the solution totally, which is because of the residue as well as the originally present. And out of this 1.59, we already know that the one which is formed as residue is 0.53. So therefore, the mass of sodium carbonate originally present is equal to 1.59 minus 0.53, which is equal to 1.06 grams. And we already know the weight of sodium bicarbonate as equal to 0.84 grams. Then what will be the weight of the non-volatile impurity? It is the mass of the mixture minus the mass of sodium carbonate originally present, the mass of sodium bicarbonate originally present, and this value we get it as equal to 4.3 grams. So our answer is option C. So what we have done here, by using a simple concept of sodium carbonate does not undergo decomposition, we could say that the entire loss of mass here happened only because of the decomposition of sodium bicarbonate according to this equation. So if 2 moles of sodium bicarbonate is decomposed, the loss in mass is because of escaping of water as well as CO2 from the vessel, that is 62 grams. But here it is given as only 5% of 6.2 grams, that is 0.31 gram. And it is from how much quantity of sodium bicarbonate? That is equal to 0.84 grams of sodium bicarbonate originally present in the mixture. Then after this, we had calculated the amount of residue formed, because the residue is now dissolved in 100 ml solution. If 2 moles of sodium bicarbonate is decomposed, we are getting 1 mole of sodium carbonate. But here we are having 0.84 grams of sodium bicarbonate. So this one will give 0.53 grams of sodium carbonate as residue. Then this entire residue is dissolved in 100 ml of solution, and then 10 ml of that particular solution is made to react with 0.2 molar 7.5 ml of barium chloride solution. So from that we get the molarity of the total sodium carbonate present in the solution. From that one we can calculate the mass of sodium carbonate. So out of the total sodium carbonate, 0.53 grams of sodium carbonate is formed as a residue, and the remaining is nothing but which is taken as originally. And already we had calculated the mass of sodium bicarbonate is 0.84. So total minus these two values will give the mass of the non-volatile impurity. I think it's clear now.